Hello, my name is Christopher Lewis, and this is my exam 4 video. I decided to do prompt 4.1, and right here we can see a picture of both DNA and RNA and all of the possible bases. Austin and Crick gave the idea of DNA being constructed as a double helix. Base pairing is the way that nucleobases is paired together, and purines are going to be adenine and guanine, while pyrimidines are going to be thymine and cytosine or uracil in the case of RNA. Base stacking is the vertical way in this picture that DNA is going to be stacked to create the double helix. Well, anti-parallel strands are going to be the conjoined bases making up the connection between both of the halves of the double helix. And we can see that cytosine goes with guanine, while adenine goes to thymine, or adenine goes with uracil in the case of RNA. Ribosome carbons, the only ones that we are really looking at, is going to be 1, 2, 3, and 5. 1 is the carbon of the ring that attaches to the base. So this is the phosphate ring connecting to the nucleobases. 2 is the carbon that distinguishes DNA from RNA. 3 is the start or end of DNA, and 5 is the start or end of DNA. So when one part of the helix is 3, then the conjoined end is 5, and the ends of both sides at the opposite side of the DNA are the opposite carbons. So if we take the top left is going to be 3, and the top right is going to be 5, the bottom left, which is the same as the top left, is going to be 5, while the bottom right, which is the same as the top right, is going to be 3. Hydrogen bonds are the weak bonds that the bases share in order to hold each other together, and they can be easily broken to have transcription occur to create RNA. While phosphate backbones, this is a portion of the vertically connected each base group to one another. They are not the antiparallel portions and provides the majority of the DNA structure. Major grooves are the largest distance between the two middle areas of a group of phosphate bonds. So as we can see with the rightmost bracket, that this is going to be a major, while the minor groove is the smallest distance between the two middle areas of a group of phosphate backbones, and this is going to be the leftmost bracket. Handedness is the direction that a DNA spirals, where most DNA is going to be a right-handed spiral, and left DNA only actually has one natural one that will occur. Left is very uncommon, and the DNA will usually not function correctly. A salt buffer can cause the neutralization of the negative charges on a phosphate base that help keep the chains together, and by taking that negative charge away, the DNA can either unravel or be separated. These are my citations that I decided to use. I used lecture 32, lecture 33, and this long citation is the pictures that I used for the DNAs.